Okay, hello everybody. I'd like to talk to you about spec-driven development, but first I'd like to tell you a story. So I'm in a sports club and did track and field. I know you can't see it anymore, but we have great runners in Switzerland. One of them is Didace Kambunji, who is the world champion in 100-meter hurdles. And if you're in a sports club like me, then you have plenty of requirements for software. So I'm doing software for my sports club for already 30 years now. We are organizing competitions for kids, and there I do software. But we also do other activities, like we have a beach party at the annual Swiss holiday, and there we need volunteers. And in 2004, during that party, someone from the club came to me and said, "Hey Simon, you're a software engineer, you did software for us, and we need a new volunteer management system because the old one is very old, it has a lot of bugs, and it will be discontinued." And I heard that there is AI, and I'm certainly sure that you can do that. And I did that. So I started 2024 doing something called vibe coding. And who did vibe coding already of you? Who get lost during vibe coding at some point? Yes, and exactly that happened to me. I had no clue what I did. So I had kind of a volunteer management system that worked more or less, but I wanted to add it more features, but I had no clue if they were really there or not, and I had a lot of code, and I lost somehow track on what I'm doing. And so I said, I may have to shift. And then I heard about something called spec-driven development that was around Christmas 2024. And then I said, okay, that's a cool idea. I want to do that. But what are the specs? And so that's the topic of the talk. I will show you how I did it finally. Maybe some words about me. I'm doing software engineering for a very long time. I'm also teaching. I'm self-employed in Switzerland. I'm working for companies like insurance companies, wholesale, retail, government, you name it. And I heard first about spec-driven development on a page. It's called AI-native-dev.io. It sounds like something official, but in fact it's a website from a company called Tesla. And Tesla started during that time with spec-driven development. Currently, they're doing more like skill management and stuff like that. But what they said was something that I really liked. So they told that you have three pillars. So you have spec-centric development. You have something called context-aware development. So you need some context that the AI agent knows what you really want to build. And then we have something called agent experience. So like developer experience or user experience. So you should have tools that work quite well or seemingly, and you don't have to do a lot with that. And I was attracted by the idea that I should write specs and not code, because I didn't write code. So in fact, I don't write code for more than a year now. I just work with that process, also with my customers. And so I was really wrapping the head around what could spec be. And back then, there were no tools, right? So we will come to the tools. So spec-driven development, maybe what's important is you start always with the specification, not with the code. The question is, who is starting with the specification? I will try to answer that as well. And the idea is that the specifications will be the intent of the application or the system that you want to build and serves as a contract between the business and the AI. And me as a software engineer in the middle, I see myself more like an enabler and not like someone that really does something. Right? Then specs should be source of truth, so we don't change the code. That doesn't mean that you don't touch the code, but we really don't change the code if we think something is wrong. We always go back to the specs and figure out why the code doesn't reflect the specs, for example. And this helps to reduce guesswork and probably may improve the quality. But there is also a warning. because when I started talking about spec-driven development like more than a year ago now, people always compared it to something that we already had. Who remembers model-driven development or model-driven architecture? I did as well, so it's like more than 20 years ago. We had some tool called Open Architectureware, for example, where we created UML models, and then we created code from the UML model, and this was not working very well. Sometimes it worked very well, sometimes it doesn't. The problem was it was very difficult to define the whole model that the code was like you wanted to have it. But the warning here is it's not model-driven. So model-driven, you could remove the code, regenerate the code from the model, and you get the same outcome every time. But AI is non-deterministic. That means you will not get the same output every time. So that doesn't mean that it doesn't implement the spec each time you do it, but it may do it a bit differently. And that's the same as you would have two developers, and you give an assignment or a task to one developer will create it like this, and the other will create it like that. As far as the outcome works, it defines a bit what works means. For example, it passes the tests, then that's fine, right? So it really depends on what you mean by non-deterministic. But here I really mean that the code doesn't look or may not look the same if you do it twice. And the last sentence is very important to me. So you're responsible for everything AI generates. So there is no way that AI could be responsible for what it does. So it's always you that have to make sure that the code works. Now, if you look at spec-driven development in practice, there are various tools. So first of all, there's a process. That's the process that I created. It's called the AI Unified Process. I will show you that. Does someone remember Rational Unified Process? I think all the people with the same haircut as I have, probably. And do someone have positive memories about the Rational Unified Process? Sometimes, yeah. The problem with the unified process, or most of these unified processes, is that they are too big, right? Too many artifacts, too many roles, too many whatever, too many processes. But mine is lean. I will show you that in a minute. And there are tools. So there are, for example, Amazon Kiro, or GitHub SpecKit, or BMAT. That's very popular. But my problem with all of these tools is a bit, I'm not working on greenfield projects usually. So I'm working for big companies like government or insurance companies, for example, and there we don't do really new development. We add features or we modernize applications, but we don't start from scratch usually. So the spec should come from somewhere maybe. And on the other hand, most of the tools, especially the BMAT tool, is very restrictive on how you have to do it. And I have a bit another take on AI-driven development, and that's what I like to show you. There's a website. It's called unifiedprocess.ai, and here you will find a process. So my process, that's for a greenfield project, by the way. Most often it starts with some kind of a vision. So some business people or whoever has an idea and want to build software, and then the regular requirements engineering process starts. So people are gathering requirements, they manage requirements. There's the International Requirements Engineering Board, for example, where most requirements engineers work along how they define the certifications, for example. And then you have something like a requirements catalog. This could be user stories or documents or any other kind of specification or requirements. That really doesn't matter. What's important in my process is that from that you can also use using AI and derive two artifacts that are very important. One is a domain model. So you need to know, here it's called entity model, but most often it's a fully domain model that you can maybe create using DDD practices, and then you have kind of a glossary and all the entities that you will have in your system. And on the other hand, I use system use cases. I will talk about that later on. That give you kind of a specification that you can use to generate tests and code from that. And very important, everything that is generated will be reviewed, hopefully, by someone, either by human or AI. It depends a bit on the process you do. But we also have other artifacts that we usually produce. I don't talk about that today, but software architecture is something that also can be derived from the requirements. So that's something that we usually do. And on the other hand, we have something called acceptance tests. And there we more or less test workflows and not just single use cases, right? So that's kind of split. And at the customer, we work like this. So we, as software engineers, we are responsible for the system use cases. So we have high coverage on the system use cases, but we don't test the workflows. That's something that the test engineers do, and they work with workflow specifications that they use to test. That's the idea. Now, the question is, why use cases? Use cases is something very old. Ivar Jakobson and other people, they were working on UML in 1992, around then. So I was 20 back in 1992, so it's a very long time. I didn't even work in software engineering back in the days. And the use cases that they created, and they are still more or less the same template, is that it adds a lot of context. Because a use case has a main flow, it could have alternative flows, it could have error flows, and it has precondition and postconditions and business rules. And this perfectly works fine for certain types of applications. So as I said, I work mostly for enterprises, so I'm doing business applications, and business applications are more or less always the same pattern, right? They have a lot of CRUD, so create, read, update, delete stuff for managing the master data, and they implement business use cases, or they implement processes that have to be implemented by you. So these are more or less these applications. Also in the keynote today, where we were talking about software in enterprises. And these system use cases, I found they could work, so they are kind of a unit of work, and this could be this specification. And so I started with use cases, and it turned out that this really works. And the good thing about this form of specification, you can give the use case documentation to the people from business. You can even give them to the end users, and they will understand what's written there, because this should reflect what they do with the system, right? And that's why I use these system use cases. We will see examples in a minute. So if we have a greenfield project, you usually have two roles that are involved. So you have the requirements engineer, that, or the business analyst or product owners, it depends how you name that role, that is working together with end users, with people from the business, and they create an entity model and use cases. And they may also use AI already to do that, by the way. So as I mentioned, the International Requirements Engineering Board, they have a so-called micro-credential. It's called AI for RE. So they have guidelines and prompts and stuff like that for requirements engineer, how they could work on requirements engineering and the requirements management with AI. And then we get these use cases, and then we can use the AI agent to generate code and tests. We have the software engineer here who is responsible for the output. He can review that. So he will review the use case. So what we usually do in the process is we go ahead, and the first thing that we do, we let AI review the use case if it's ready for implementation, for example, and then we generate test and code. Depending on what you're doing, you could use also test-driven development. So for example, if you're doing a REST API or a library or something, then test-driven development works very well. If you're doing UI development, then test-driven development may be kind of hard, because you don't know exactly how the UI may look like before you start, right? But that's the greenfield flow. But usually we have a different flow. And the different flow is called, I call it brownfield workflow. And in the last like 7 years, I was more or less working in modernization projects. And I'm currently working in 2 modernization projects, one for Covenant and another one where we kind of recreate the ERP system for the largest wholesale company in Switzerland. And we use that workflow. So here we don't start with the use cases, we start with what we have. So that means we take the code, we take documentation, we take Jira, we take Confluence, everything that we can find and feed it to AI and let AI extract the use cases. We also have sometimes business processes that we can take to get an idea what use cases we could have in the system. And this will recreate the missing pieces that we have currently, and from there we can generate a new application. So we don't do something like COBOL to Java transformation that Anthropic was talking about a few months ago. We really just reverse engineer the specification and then create the code. The reason for that is when we started with the modernization project 2 years ago, we were doing it manually, so without AI, more or less. And then the guideline was, don't create new features. We were not allowed to add new features because we wanted to transform the old application, which was Eclipse RCP together with JBoss and EJBs, to Spring Boot and Vaadin as a front end, right? And when we finally went into that process here, we realized that now we can do whatever we want. So as long as we can describe it in the specification, it really doesn't matter if it's an existing feature or a new feature. And this gave our project a huge boost because now the end users get new features that they were waiting for many years already, because in the old system it was probably not so easy to implement, and we can do that now. And that has a very positive effect on the modernization project, because usually modernization projects are not very well received because they change a lot for the end users and they prefer to stay with the old system usually. So that's kind of a benefit. Now, for this talk here, because we are at Spring I/O, I created something for you. I created a brownfield approach for you. You may all know Spring Pet Clinic, right? If you haven't seen it, I can just go to it. Does it run? No. Then I start it. So Spring Pet Clinic is called Spring Pet Clinic, by the way, because for Java EE or J2EE, there was the pet store. That was like kind of the demo project for J2EE. And Spring also was looking for kind of a similar project, and they created a pet clinic. So that's the reason why. And what we can do here, we have a home screen. We can find owners by name. And then we can edit the owners, and we can add pet visits. So we have something like that. And we also can list all the veterinaries that are working in our pet clinic. So that's the idea of this project, and it has an error page. So that's it. And what I did, I recreated the use cases for that project, but this time as use cases, and I want to create that as a new modern application. That was my idea. And what was created, in fact, was the entity model. So as you can see here, everything is code. So also the diagram here, that's a mermaid ERD diagram that was created here. That has just the names of the entities, because you don't need the attributes here. That's just to visualize the dependencies between the entities, for example. And then down here we have kind of tables with attributes, description, tape, precision lengths, and some validation rules. And that was extracted from the old code. And this will be then used for sure to create the data model and also the domain model. And on the other hand, we have recreated the use cases. And these use cases here, let me make that bit bigger, are grouped. So I didn't tell AI to group that, so that's something that it did. And we have a welcome page, we have the veterinarian's view, and we have the owner management and the error handling, more or less. So that's pretty much what we wanted. And then I told AI to also recreate the use cases. And here you see a use case for Cloud Code. I have a marketplace. So marketplace is kind of a way how you can distribute plugins for Cloud Code that may contain skills, subagents, and MCP definitions. And there is also a use case template. That's why it always looks the same. We also use, by the way, status tracking on the use case. So we don't do in all projects that I'm currently working, we don't use Scrum anymore, so we don't have any sprints left. So we really work use case by use case, so to say, and that's more a Kanban flow and not a Scrum flow with fixed time boxes, because that doesn't make sense. And to give you some numbers, so that's a very small use case, so we can go through it. So we have the use cases, who's the actor, what's the goal, and then we have some preconditions. I mean, the first one is a silly precondition. You can delete that. That doesn't make sense. And then we have the main success scenario. User clicks on a link, and then it displays the grid. Here we don't have any requirements for the UI, but usually you have maybe a UX designer who uses Figma, for example, and Figma is quite well integrated because it has an MCP server. That means also AI can generate Figma designs, but AI can also read through the MCP server the Figma design. So you don't need to export that somehow. The AI can directly use that. That's a way to go. Or in another project, in the government one, we don't want to change the look and feel of the UI, so we just use screenshots as the input for AI. And that's good enough to know the structure of the code. Here we have everything in text, so that means it tells that the grid has first name, last name, and then a comma-separated list of specialties, for example. And then we have some alternative flows, because there must be a REST API, and we have some post condition that what happens when it works. And then we have some business rules. I mean, the first one is not a business rule. That's more a constraint. That would be in a kind of a non-functional requirements documentation. And then we have other things that may go here. And in practice, this use case could be very long. So we have use cases around 26 pages, for example. So if you would export it in Word. And in the government project, the relationship between requirements engineering and me is I'm the only developer currently for that proof of concept. And I work 1 day per week for them. And they have 2 full-time requirements engineers working on the specs. So there's quite a shift from software engineering to requirements. But this time, it's for them, it's a big chance, because replacing the old system is quite difficult, because no one knows what it actually does. So we have code, and we have a lot of bugs, and we have a lot of missing features in the existing application. And now we're trying to reverse engineer that and fix that. So that's like a 2-phase thing. So we recreate the use cases. That works pretty well from the code. And then they spend quite a lot of time, first of all, to go to the application and verify if the use case is correct. And then secondly, verify if the use case does what it should do, because in some cases, that's not what the application currently does. So that's a lot of work on the requirements engineering side. On the ERP modernization side, we don't have that much effort, because we just can recreate the use cases. And we as developers, because we are experts in the system, can do the review by our own. So we know the existing system, or not I, but the other people working with me know the system so well that they can review the use cases. So we are not having requirements engineers on that side. And that's it. And I already started the application, or created the application for you. So some advice. Do the scaffolding of the application by yourself. So go to start.spring.io and create your application. Maybe also follow what Daniel was talking about before. So create your security configuration by your own, maybe with the help of AI. But don't use, for example, Claude Code to create your application. Because if you do that, the next step that you have to do is to modernize this application, because Claude Code will probably create a Spring Boot 3.7 application and not a 4.05 or something, right? So it's better to do that by your own. And you can also use guidelines for, I will show that for testing and for the application. And that's the first view that I already created, because that's just displaying the picture. The design is a bit different because I didn't tell how the design should look like. But what I like to show you is, if you want to implement the use case too, so this, let's go back to the old application here. So we want to view the list of the veterinaries. We can just go here, and as I said, I have some plugins for Claude Code, and I just can type implement use case 002. So that means I don't do any prompting here. So the question is, where's the prompt? This slash Vadin AI app Vadin Chuk implement is a skill. So in the beginning, Claude Code was distinguished between commands and skills. Now everything is a skill, and you can directly call skills. And if you go to the marketplace, for example, that's a simple GitHub repo, then we can find this skill somewhere here. That's the implement skill. That's just the skill markdown. By the way, that's more or less the agent skill standard, and could also be used with GitHub Copilot or any other tool. Just the marketplace and the plugins are specific for Claude Code. And here you see a skill, and the skill has a name. Obviously, that's how you call it. And then you have a description. So this part here is called the front matter, and this tells AI when to use the skill. So in my case, it doesn't have to figure out to use it because I directly call it. But if I would say just implement use case 002 without the slash in front, then it will probably find that, because here in the front matter says if the user wants to implement the use case or build a UI or something like that, use that skill. And there are tools like Tessel, for example, where you can validate your skill. So they can evaluate your skill, if the skill is okay, if the skill is used or can be used. They even work on testing tools that they use or execute the skill somehow and then monitor the output and give you advice how you can improve the skill. And that's what I also did here for that skill. And what we have here is we have some don'ts and do's and the workflow and stuff like that, right? And this skill here is specific because I'm using Vadin and Chuk as libraries. That's made for that one. I'm also working for a customer that is using .NET, so we're modernizing also kind of an ERP system that is Win Forms with direct access to the database, so a two-layer application or a client-server application, and we are creating something new with React and the .NET framework, and there we have specially created skills for that stack. So the skills should match the stack that you're using or the things that you use. There are also skills that are not relevant, not related to a stack. They are in this AI app core. And here, for example, we have a use case, not the use case diagram, but the use case spec skill. And here in this skill, we have instructions as before, and we also have a template. So that's why the use case description in my example pet clinic project looks like that, because it used the template from here. So you can feed a lot of things, but you should be careful, because skills, if you don't know where they come from and you don't review the skills, can be dangerous. So skills can be used to do prompt injection or a lot of other bad things. And that's why you should really take care which skills you want to install and use by the end. A lot of companies or people are working currently on skill management because somehow you have to share them. As I said, it works out of the box because it's integrating Cloud Code. But if you have different agents, then you may have a centralized agent skill management something, but we don't have yet something that I would call a perfect solution. So that's here. So here I get asked for something, and we let it run. It takes around usually 3 minutes or something to create that. Now, I already talked about skills, so you can use that to have repeatable skills, defined that all the people working in the project have the same skills. So that means either you have company-wide skills or you have public skills, but you can also have skills that are for the project. Then you can just put it to the Git repo and everybody can use it. Another thing that is also, in my opinion, quite useful are MCP servers. For Java, there are, for example, from James Ward, who is also here, he has created a JavaDoc MCP server, so the agent can use the JavaDoc directly. Then we have, for example, a Vaadin MCP server that was created by the Vaadin team who is here. And I created one for Juke and one for Caribou testing. That's a testing framework. And these are very helpful. And there is a debate if you want to use MCPs or skills. A lot of people say you don't need MCP anymore, just use a CLI and a skill. But that's not the truth, because most of the time if you have MCP for documentation, they use a vector store, and then you can do vector search for similarities search, for example, which is more efficient, and that's why I still prefer MCP server for them. And there are other guidelines. So first of all, if you're doing Java development, you already have guidelines, and the guidelines is the POM XML or the Gradle file, where you define how the application should look like. I most often also use Spring Modulit, so this already gives some structure in the application. And finally, in my example project, I created 2 guidelines, one for architecture, so it says, for example, package by feature, and then we have UI and the domain package inside and stuff like that. And we also have a testing. We don't do testing today, but Vaadin is special, so Vaadin is server-side. It's not server-side rendering, but server-side programming model. That means you can test Vaadin application, so-called browserless. So like you use mock MVC, for example, you don't need a Tomcat to run a Vaadin application, and these tests then run as fast as unit tests, more or less. And so you could have many of them, and then we also have, for example, in that example I will show you later on, I have a use case annotation that helps AI to do the drift management, because sometimes you have a drift between implementation and specification, or specification and test, and you can use AI to figure out what's exactly tested and what not. Okay, let's see how far we are here. That's done. So let's go ahead and restart that. So. And we have our veterans table here, right? And obviously that was a very simple case, right? It can't fail. It even produces more or less similar results every time I run that, as long as I stay with the same tool and with the same model. Then it produces kind of more or less deterministic results. Right. So let's go to the main branch, like this. What I created here for you is an example project, and you see here that it has some tags. There's an initial tag where you can start with it, so that's kind of the reverse engineered project. And I also have a full implementation that you can see how this looks when it will be done. And this one, for the last like 5 minutes, I like to show you the testing part of that If we go to the FET, for example, you see that the tests in that case here have the same name as the use case. So as I said, we really test use case, or we implement use case by use case, and we test use case per use case. So even if we have two use cases using the same view, for example, we have two tests, two separate tests. And these are regular Spring Boot tests with test containers. And these are so-called browserless tests. So that looks like this. So we can navigate to a view. We can get a grid from the UI. We can check the size. We can do assertions. We can get the first row. We can assert on the row content and stuff like that. So we have selectors like you would do end-to-end testing. And as you have seen in my process, we also have the acceptance tests. So the acceptance tests in my projects are done with Playwright. And these are real black box tests, because these here are all white box tests. That means AI, to create the test, not only sees the spec, it also sees the implementation. And that means it tests what's implemented and specified, hopefully. And it hopefully finds out if there is a drift between implementation and specification, right? But these tests are just for us and are more kind of regression tests. The more important tests are the workflow tests with as end-to-end tests, because that's the truth for the user, what he sees. But here to show you, I created this annotation just for me, that I have a reference between an ID and the business rule, and I also have kind of a beta IntelliJ plugin where I can navigate from the business rule to the test and to the implementation and stuff like that, right? So that's kind of the idea here. Now, something that I also like to talk to you is about the impact of the architecture, because if you're doing spec-driven development or AI-driven development at all, you should reduce the context. We heard about Spring Monolith, which is great if you want to build a monolithic application, but if the monolith becomes big, so for example, the ERP system that I'm talking about, we have over 1,000 database tables in that system, so that's quite a big system. I also modernized a bigger one, which has double the size in database tables, and that's simply too big. It's not too big for AI, but it's also too big for humans. So you have a huge load if you're looking at the whole system, so it's probably better if you split it, and my preferred way to split that is self-contained system, because I try to keep UI, business logic, and database in a silo, in a vertical slice, and that's also very, very useful for AI. And what's also very useful is if you have kind of a full stack framework. So this may be Vaadin, as I do. This could be Timely, for example, or JT or something more server-side rendered. But you could also, we are here on a Java conference, but you can also use like React full stack, for example, and then you have a single JavaScript stack. The reason for that is that you just have to create the guardrails and guidelines for one ecosystem. So in Switzerland, it's very popular to have Angular in the front end and Spring Boot in the back end. So that's called the government stack, or I call it the government stack. And there you have a problem, right? Because everything you do, skills, MCP servers, guardrails, guidelines, all the files, has to be created for both stacks. And that's kind of more work, let's say it like that. But it really depends on what you really build. Microservices, on the other hand, may also be a problem, or not a problem, but you have to find a way how to work with that. Because if you work with AI on a use case, for example, you need all the code that is involved in the use case locally, or wherever your agent runs, right? It can also run on a pipeline or on a build server or something. But you need kind of, I would say, probably a monorepo where everything is included to work efficiently with AI. Or you need, if you use microservices, a very good open API documentation that AI can figure out which API must be called depending on the use case, right? So that's kind of a trade-off. I would say Modular monolith, probably, as Oliver said in the morning, is probably the best starting point, also for AI. Cool. So to conclude, in my opinion, or in my experience now, specs help to reduce the non-determinism. So if I would do vibe coding, I would get something. But I would have to read the code and to reprompt, and so I can really rely on the specs and check them out. So we have very good results. To be honest, we don't do everything like that. So this spec-driven thing works very well for these business application types, right? So if we have complex business logic, for example, this is very often done more in a test-driven way, where the tests are written first or generated first, and then the code is generated last, but not based on a use case, probably, maybe more on a interface specification, so to say. Then what's also important for me as someone working on software modernization projects, spec-driven may become way more sustainable. Means if we have now the ERP system fully spec, we could go ahead and recreate it in 10 years, maybe, hopefully. Because AI will be better and faster, I assume, and then we can just generate that in another stack. But currently, and that's very important, you should review, understand, and test everything by your own. So you should really look at the code, and there it's beneficial if you know the stack very well. So because I know Vaadin and Jouk for many years already, I just can scan the code. So I don't need to read every line. Because if I look at the code, we can maybe do that in the last minute or so. What it created here, or let's switch back, or no, let's use that. It doesn't really matter which one. We have a repository, and I know that that works or looks good because I know Jouk, right? We also have a record here. That's also probably a good thing, and that's it, right? If I would do the same demo with JavaScript, for example, which I also do, so I do workshops on spec-driven development, and also had a customer who said, you must do JavaScript with React and React server components and stuff. And I looked at the code, and I didn't really understand what's going on. It worked, but that's the dangerous part of that, right? So you must understand the code. And on the other hand, architecture and domain knowledge is yours, or the company's, and not AI. So you really need to understand the domain, you need to understand the architecture. You should do, also with the help of AI, the architecture work, and then you will get much better outcome when you do that like this. So that's it from my side. I think we have maybe one question. Someone has a question? No? All clear? Okay. Thanks a lot for coming. And I'm here tomorrow if you have any questions or want to see a demo or something, just approach me and we can do that together. Thank you very much.